FeatureCAM now has the ability to smooth the azimuth and elevation axis independently of each other, using one of several new smoothing options. One such option is the new stepped stabilization smoothing. This type of smoothing will stabilize or lock the rotary axis movement by maintaining a fixed tool axis as much as possible within an angular range. The toolpath will appear as a series of 3+2 axis segments with 5 axis transitions between them. The transitions can be either completed on surface or with a lift. In this example you can see we have this simple block, and all we want to do is do a pencil milling operation in the bottom fillet. There are 4 toolpaths already pre-created. The first one uses no smoothing. If I look at this toolpath, into the pencil, into the 5 axis, tool axis smoothing is turned off, but you'll see we're using a lead lean operation, tilting 45 degrees as a lean angle. We're also using a tilt for gouge avoidance, in this case a lead angle. If I go ahead and play the simulation of this toolpath, so the tool comes into position, using Alt F3 you can see the tool is moving quite a lot in both the azimuth and elevation as this makes its way around the part. What we want to do is smooth this out. If we look on the machine, in this case I'm using the Hermele C30, and again rotate round, play the simulation, we can see the amount of motion on the table. This is what we want to smooth out. First stage of smoothing, in this case, is smoothing the elevation only. If I go into the properties, into the pencil, into 5 axis, note that we've ticked the box for tool axis smoothing, and we've gained an additional tab. Under this tab you can see the first area is elevation and the second area is azimuth. In this case, under the elevation we're using the stepped with links, and we've got a maximum angular correction of 3 degrees. We've also applied a smoothing distance to smooth out the transitions. Again, playing the centerline simulation. So we still have some motion there, but the tool is moving a lot less in the elevation. Again, we can verify this with the machine tool. So we still have some azimuth rotation, but we've tried to minimize the elevation. The next toolpath works with both the azimuth and the elevation, and in this case, if we look at the tool axis smoothing, you can see we've got step with links for both azimuth and elevation, and we have the same maximum angular correction. Again, using the Alt F3, I rotate my toolpath around. You can see at each transition we get a link as the tool lifts off the part and changes its axis. So this is the progressive 3+2 motion. In this case we've chosen a step over rapid distance. That's allowed us to link those toolpath segments. I can continue this toolpath around the part. If I turn off the shading, you can see the links around the component. In this case, building up, especially in those corner regions. Again, viewing on the machine. You can see the incremental changes in the table with our links between each part of the toolpath. Our final toolpath uses a similar method, only this time you can see we're using stepped on surface, and we've given it a much larger angular correction. This will help the blend between the sharp corner changes as we make our way around the part. Again, looking at the centerline simulation, you can see the smooth motion of the tool as we go around the part. This is especially evident, you can see, in this tight internal corner where the tool stays at a reasonably constant angle. We end up with a much smoother toolpath and a better surface finish.